Okay, looking at a relative atomic mass question here for A-level chemistry. So 3.3, a sample of chromium contains 4 isotopes and has a relative atomic mass of 52.09. Table 2 shows the mass number and the percentage abundance of 3 of these isotopes. So we've got 52, 53, 54 and their relative abundances. We then have the question, determine the percentage abundance of the 4th isotope. I'm labeling it Z for algebraic purposes. Show by the calculation the mass number of this isotope is 50. So you've got to recall the equation for working out relative atomic mass, and that is that the RAM is equal to the sum of the mass number times the abundance for each isotope. So we need to times the mass by the abundance for each isotope, then divide by the total abundance. In this case, that's going to be 100 because we're using percentages, and that's going to give us the RAM. Now, we need to set that equation out and then solve it to find our 4th isotope, Z. So first of all, I'm going to set out the equation of mass times abundance for each of our isotopes. So 52 times 82.8 for the first one, 53 times 10.9 for the second one, and for 54, I'm going to do 54 times 2.7. And then that's all going to be over 100, and that's going to be added to, we need to find the percentage abundance first of all of our missing isotope, and that's quite simple. We know the total abundance is 100, so we're just going to minus 82.8 minus 10.9 minus 2.7, and that's going to give us 3.6. So we know our missing abundance is 3.6. I'm going to multiply that by my symbol that I was going to use, which was a Z. So I'm using a Z to represent the mass number, which we know is roughly 50. The question tells us that it's going to work out to be 50, but we need to show it by calculation. So we're dividing by 100, and that equals 52.09. So let's simplify this calculation and get to our answer to show that Z is equal to 50. So I'm going to first of all multiply out the brackets for all of these. So I've got 52 times 82.8, that's 4,305.6 on my calculator. And then I've got 53 times 10.9 is 577.7. And then I've got 54 times 2.7 is 145.8. So I can add that all together and write a more simplified version, a little neater version, which will be 5,029.1 plus 3.6 times Z. And that is equal to 52.09 divided by 100 for the 5,029.1 and the 3.6 times Z. We're not dividing the 52.09 by 100. Okay, so to get rid of the divide by 100, you know what you do? You multiply both sides by 100. So let's times both sides by 100, and that gets rid of the 100 on the left-hand side, and we just rewrite the equation 5029.1 plus 3.6 times Z, and that is now equal to 5,209 because we multiplied the right hand side by 100. So what do I want to do next? Well, I want to get rid of this 5,029.1. So to get rid of that, I'm going to minus 5,029.1 from both sides. And when I minus 5,029.1 from both sides, I end up with 3.6 times Z. So we're really simplifying here. And that is equal to 180. And now I know that 3.6 times Z is 180. We're just going to say, hey, I'm going to divide 180 by 3.6. So I'm just going to do 180 divided by 3.6. And that is going to give me Z is equal to 50. And here we go. We've just proven that the mass number of the 4th isotope is 50. And that's going to get us the 3rd mark. Sharing's caring. Hit the like, punch up the bell, subscribe. Let's get to the marks.
You're still here? It's over.